Okay, so let's have a look at our sorting algorithms, starting with a nice easy one called bubble sort. Now, with bubble sort, we basically take two values and we compare them. If this value is, let's say it's ascending first of all, so we're going from the lowest to the highest. So if this number is less than this number, then we don't do anything. And then we go on to the next two. Is 12 less than 1? Is 12 greater than 1? Yes, it is. So I would swap them around. 12 and 2, yep, swap. 12 and 4, yep, swap. I picked the wrong numbers here, I think. 12 and 5, yep, swap. 12 and 6, yep, swap. 12 and 7, yeah, swap. 12 and 9, yes, swap. Okay, now you notice that isn't sorted yet, but it has meant that this last one is in its sorted position. So basically we just keep repeating that process until we've gone through the whole thing and there have been no swaps. So we've gone from 0 to 7. Oh, I'm getting 9 here. I really messed up somewhere. We've gone from 0 to 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. I've had that for ages. Lots of videos. Oh well. Anyway, so I'm going to keep going until there have been no swaps. So if I ever get into the situation where it is like 1, 2, 4, 5, 6, 7, 9, 11, 12, then I know that it has been completely sorted. Now again, there's multiple ways to do this. Some people do for, if. I usually do while for if, and you'll see there's various variations on that. Okay, let's get into the coding then with this one. So this is going to be our bubble sort. Okay, and then I can just kill all of this, but I'm going to leave my array up there, and it's going to be a bubble sort, and I'll put in the YouTube link a bit later on. Okay, so what are the different stages? Or what variables do we need? So, let's call it init for now, declare init, whatever you want to call it. So, I'm going to have my current position, which is going to be n, but I'm going to get that from my for loop, so I don't really need that. What I do need though is something to say if there has been any swaps. At the start, that's going to be false. At the start it's going to be true because I want the loop to happen at least once. Okay, now, if this were not Python, we could do a precondition loop, a postcondition loop to do it once, but because it is Python, we have to do it as a precondition loop. Now, again, there are different ways to do this. I'm going to start with a while. I've seen it in the book and the exams a couple of times where they do for. And you've got to kind of be ready for both. So think about how it could be done in different ways. But we're going to say while swapped. Well, we're going to set swapped right away to be equal to false. Okay, why that? Well, again, it's just because of this precondition, postcondition thing. We want to be able to do it at least once. So we're going to say swapped equals true. And then we're going to use our while swapped to loop through it. Now, at the very start, we want to reset everything and say we've not swapped anything. And then I want to do my n and n plus 1. Now, important factor, if I did the last one as n and n plus 1, I'm going to have an error because I've gone outside the index of my array. So I have to do for x in range 0 to the length of numbers, and I'm going to subtract 1 because this last one is going to be from n and n plus 1 here. Now, I want to say that if, now again you can write it in different ways, I'm going to say if n is greater than n plus 1. Now, I don't mean n and n plus 1. What do I actually mean? I mean I could change that to n, couldn't I? Is that going to be better for you guys? For n in range 0 to... Okay. If numbers at position n, okay, so I'm not checking the indexes, I am checking the values at those indexes. Okay, so if numbers is greater than, so if this number is greater than this number, then I want to swap them. But to do that, I'm going to need to have a temp variable. I'm going to set my temp to be minus, just because that's what we've been using a lot for empty stuff. So if the numbers is greater, well, first thing I want to do is I want to set the temp equal to the numbers n. Again, there's different ways you could do it n plus 1 at this point, but anyway, I'll try and keep it simple. I'm going to set numbers at position n equal to numbers at position n plus 1. It helps if I put it in the bracket. Now, once I've swapped them around, I then need to move my temp value back into numbers n plus 1. So numbers n plus 1 is going to become equal to the temp. And this is probably the most confusing bit about it. So let's think about our values at this point in time. So let's change it so that this is going to be a 10. So n, or numbers at n more specifically, is going to equal 10. Numbers at n plus 1 is going to equal 9, because it's at position 0 plus 1 is 1. Now I've said if numbers n is greater than numbers n plus 1, then my temp is going to become equal to numbers n. Then numbers n is going to become equal to numbers n plus 1. 9. And then the numbers n plus 1 is going to become equal to the temp, which is 10. So all that's done, all this code means is swap these two values around. And that's the sort of crucial part of a bubble sort, is moving the stuff through. Now, have I swapped anything? Yes, I have. So if I've got into this if, that means I have done a swap, which means my swapped has been set to be true. Okay, and the reason for that is, if everything were in order, there wouldn't be any swaps. So when we start the for loop to the end of the for loop, there'll be no swaps. If that's the case, then we're sorted. Otherwise, we're not sorted, and we have to keep repeating that for loop until all the numbers are sorted. Okay, now is there anything else I have to do? I don't think so. So let's see. So if I were then at the end to print my numbers, fingers crossed, they should all be in the sorted position. 2, 6, 7, 9, yay! Success. A couple of things to notice is I could make it more efficient. So with a bubble sort, each pass, each for loop, we know that the last value is sorted. So the first pass of the for loop, the 7 is sorted. The next pass of the for loop, the 6 is sorted. So we actually don't need to keep checking this every time. We could actually change this by an extra -1 each loop. So -1, -2, -3, and that would make things more efficient. The other thing to think about is our double for loop. So a double for loop basically says for the number of items, so we know that 7's been sorted the first time, 6, 5, 4, 3, 2, 1, 0. So how many loops is that? 1, 2, 3, 4, 5, 6, 7, 8. So we could replace that with another for loop. So for x in range, and let's go from 0 to the length of numbers. So this would be an alternative way. We could get rid of our swapped variable and the other thing, and fingers crossed, yay, that still puts it into order. So two different ways of doing the same thing. Again, my preference is this way because it stops once we have sorted the array. The other one, even if there was just one swap at the beginning, that means it would keep sorting the array line by number by number, even though it was already sorted, so it would potentially be less efficient. Okay, hope that's helpful. See you soon. Bye.